Welcome back to the Backtrader series. This is your host Ali, and in today's video we're going to learn everything about the data feed components of Backtrader. Today's topic will be the first in our series, data feeds. And if you haven't watched the introductory video, I highly recommend watching it before proceeding with this one. The link will be in the description. And please, do not forget to subscribe to my channel if you like this type of content. As we discussed in our previous video, one of Backtrader's core components is data feeds, which controls everything that has to do with data, whether it was regular financial data or any external data. Well, the methodology used by Backtrader to load any data is pretty simple. It is 3 steps away from running your backtest. First, we need to prepare the data, parse it into the required Backtrader format, and finally load it into the Cerebro. Wait, but why do we need to parse the data in the first place? Well, as you may know, data can come in many different forms and shapes. Time objects can have different formats. Therefore, we need to specify the time format as per the Python datetime object format standards. OHLC or open high low close, volume and open interest can have different column names or orders. We have to tell Backtrader which is which. What if our data contains 10 years of a certain stock daily candles, but we only need the last 2 or 3 years for our analysis? Thus, we have to tell Backtrader at which date to start and when to stop. What if our our data's time frame is like, for example, 3 minutes for each candle? We have to tell Backtrader which time frame are we using. Take this table as an example. Time can have different formats, can have a different format. OHLC columns can be different or in a different order. For example, high, low, open, close. Volume or open interest can be unavailable, and also a certain time range is needed. What if this data was a CSV? We'll all know that the CSV can have a different separators other than the semicolon, for example. Or for example, if it was a pandas data frame, the table can have multiple layers, multiple layered headers, or no headers at all. We have to specify that as well. Some data sources are standard, and luckily for us, the Backtrader comes with a set of standard data feed parsers that can save us time specifying the format and setting the parsing attributes. Moreover, we can use any of those standard data parsers to build our own subclass to make it permanent or create our own standard library. Let us take the PandasData parser as an example. Consider this conceptual example. We have a pandas data frame named df_Tesla. The D column is the date, and it has been already parsed into a datetime object. O, or basically, is the open. H is the high, L is the low, and C is the close. This means we have to tell the data parser that the column is this column, or column 0, is the datetime. Be aware that Backtrader follows the Pythonic indexing, so the first column is indexed as 0. By following this, open is the column number 1, high is column number 2, and so forth. Since we don't have the volume nor the open interest in this data frame, we have to set them as -1. -1 means that it does not exist, and the Backtrader will not look for it or will not parse it basically because it does not exist at all. We are going to try several scenarios from importing pandas data frame to locally stored CSV data file. So finally, it's time to code. Let us get started. First of all, we're going to import the Backtrader. I assume that you have installed Backtrader as BT. Import pandas as PD. We're going to use the Yahoo Finance library, yfinance as YF. Ta-da! Now, let's download the Tesla data frame, the Tesla stock for as long as the Yahoo can give us, Yahoo Finance. Tesla df equal yf.download tickers equal to the ticker name for Tesla is TSLA, and voila, Tesla_df. Here we go, we have the Tesla data frame. First, we have to import, or basically, in order to add the data to the Backtrader, we'll have to parse it, as we mentioned earlier. In order to parse the data, we'll have to give it a name. For example, let's call it the Tesla_df_parsed equal bt.feeds, which controls everything related to data feeds. This data is pandas, so we're going to use the pandas data feed. PandasData. PandasData takes the column data, takes the parameter data name, which is equal to Tesla underscore df. Now, basically, since this data frame has the index as date, and it's already been parsed into a datetime object, this means we don't have to specify the datetime format for this pandas data frame. What we're gonna do instead, we're gonna tell the parser that the open is as at the column number 0, the high is at the column number 1, 2, 3, and so forth. Note that since the datetime is the index, the date is the index, we don't have to specify the open as the column 1. We'll have to specify it as the column 0. It follows the simply follow the basic Pythonic indexing. So basically, the open, so we'll have to tell the datetime equal to none because it's already the index. Open is equal to 0, sorry. High is equal to 1, low is equal to 2, and we're going to use the adjusted close, which is at the column number 0, 1, 2, 3, 4. Close is at the column number 4. The volume is column number 5, apparently. 5, and since we don't have any open interest column, we're going to open interest is equal to -1, which means that the open interest does not exist. And voila, here we go. The Tesla's data frame has been parsed and it has been added, or basically has been parsed. Later on, we're going to learn how to add the data frame, how to add it, or how to add the parsed data frame into Cerebro. We don't worry about this right now. We're going to take it further, or we're going to learn it later on. What if our data frame was CSV, Tesla underscore data frame underscore parsed to CSV? We're gonna call it tesla.csv. What did I do? Oh, sorry, it's not the parsed. Tesla underscore data frame. Sorry, my bad. Let us first of all, let's see how the CSV will look like when we try to read it. df is equal to pd.read underscore CSV. It's the Tesla.csv without any data parsing or anything. df. As you can see, the index is not the date, and the date time has not been parsed. It's simply a string, basically. The open, high, low, close, blah, 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 everything is as normal. But this means that we'll have to parse the date into a datetime object, or parse it, or directly tell the parser that this column is a datetime object, and with the current format, with a specific format, the open, high, low, close. Note that in this specific CSV file, since we have another index, since the index is not the datetime, we're gonna tell the parser that the date is at column 0, and open is at column 1, which is different from what we've done in the previous example. So Tesla underscore CSV underscore parsed is equal to bt.feeds. To use a CSV, we'll have to use the generic CSV file, GenericCSVData, and the data name is equal to the CSV file name, which is tsla.tesla.csv. And in this case, we're gonna tell the parser that the date time is equal to is at the column 0. Open is at column 1, as we did in the previous one with shifted columns. High is at column 2. Low is at column 3. Close, we're going to use the adjusted close, which is at column 5. Volume is at column 6. And open interest is not there. It's not available, so we're gonna specify it as -1. Open interest is equal to -1. Interest, yeah. So the datetime format, now we'll have to specify the datetime format for the datetime, basically, which is year, month, day. dt format is equal to, we're gonna follow the formatting rules of the datetime, of the Python datetime library, which is in this case percentage capital Y for the year, dash month, percent M, small m, dash percent T for the day. And voila. We have the Tesla CSV, the parsed one, parsed file. Note that there are many parameters that you can modify later on, but it's not our case. Let's focus around the introductory cases in this lecture.